Welcome to Gabversity, and let me share with specific people. I can't share this with anyone. So I've still got these lectures to go for quantum mechanics. Alrighty, welcome to Gabversity, where facts and feelings were running away from a bear. Facts made it, feelings didn't. And let us continue. So, in our last lecture, we were talking about Jupiter, and we're now in the Jovian planets, the outer ones of the solar system, basically the failed gas giants, the ones that failed to ignite and turn into the sun. They tried, they failed. And you know what? That's life. Many people try and fail. And, you know, for every one success, there might be millions and millions of failures. But you see, that means that when one person succeeds, we all do. Because of the odds, no more gas. they were out of gas. Alrighty, so now we talked about Jupiter. Now we're going to talk about Saturn. We spoke about Saturn's rings. Actually, we didn't talk about Saturn's rings. We spoke about Jupiter's rings. All right, so Saturn's smaller... Okay, here are the smaller ones. So... we've got Enceladus, Enceladus, maybe it's Enceladus. We have Dione, or Dione. We have Iapetus, or is it Iapetus? We have Phoebe. We have Hyperion. We have Rhea, Tethys, Mimas, and Titan, right? And Hyperion and Phoebe are not even circular because they were so small that the gravity could not squeeze the rocks into a spherical shape. And I'll show you them now. Here we have Titan, as you can see. Then we have here Enceladus, Dione, Mimas, and Tethys. Tethys sounds like male genitalia. It sounds terrible. All right, here we have Iapetus, I guess, or Iapetus. I have no idea. Phoebe, Hyperion, Rhea. Do you have diarrhea? Haha, hilarious. And that's Earth's moon to show you the comparison in size. So Earth and Titan. Titan is sort of just a bit bigger than the Earth, right? And that's what Hyperion and Phoebe look like. They're just rocks. Thank you for looking at the couch just there for a second. All right, these lecture notes are driving me crazy. No, get out of my face. Where do I put them? Sorry, these are the lecture notes we've used, which I can now shred. And then we've got these lecture notes, which we have to look at. All right, so the next one, Saturn's smaller moons. Saturn's smaller moons are formed of rock and ice. Rock and ice, heavily cratered and appear geologically dead. All right. It looks like they're just basically rocks. Hey, supernova, high school teacher's back. Okay, leading upper right side darker than the rest of the surface because of dark deposits. That's a bit weird. Have a look at this one. Oh, where's my lecture? Where's my magnifying glass? There it is. All right. So, as we can see, that one there's got dark deposits on the top. We're going to have to find out what they are. Okay, and Phoebe and Tethys heavily cratered ancient surfaces, possibly active for Enceladus, we're not sure. Regions with fewer craters containing parallel grooves, possibly filled with frozen water. Could have frozen water. Let me enlarge this so we can see what's going on. So it looks like they have very strange grooves happening there. I wonder what those grooves are. They could be filled with frozen water. All right, that's interesting. The origin of Saturn's moons. It looks like, unlike Jupiter, the moons did not all come in at the same time. So they're probably captured icy planetesimals, because if you guys know, at the outer boundary of the solar system, there are many little planetesimals like Pluto. And Pluto's part of that. They're called the Kuiper Belt, right? And that sort of circles the outside of the solar system. Hey, Sab. And so Saturn, with its mass, probably, you know, sucked some of those in like a bit of a vacuum cleaner. They actually affect each other's orbits. So they're like dancing around each other. That's insane. Yeah. some of the orbits are only 60 miles apart. Can you imagine? Imagine if the moon was 60 miles from the Earth, right? Like it would fill up the whole night sky and every tide would be a tsunami. All right, small moons are also trapped in Lagrange points of larger moons. What are Lagrange points? Let's look up Lagrange points. Lagrange points. I know what it is mathematically, but I don't know what it is in astronomy. Is a location in space where the combined gravitational forces of two large bodies, such as Earth and the Sun or Earth and the Moon, equal the centrifugal force felt by a much smaller third body. What does that even mean? I don't know what that means. Equals the centrifugal force for... Does that mean that when it reaches a certain point... All right, let's have a look here. All right. So several planets have satellites near those points. Artificial satellites have been placed there, and Lagrangian points have been proposed for a variety of future uses in space exploration. So let's see what they are. Okay. Three-body problem. In the chapter, he considered general from that second chapter circular orbits. All right, let's try. Okay, explanation, right? Here we go. The one where the gravitational attraction of the second mass partially cancels the first one's attraction. I'm thinking in my head, possibly, as opposed to thinking in my bum, but I'm thinking that maybe it's like a point where it sort of feels like you have no gravity on the planet. Is that what they're saying? The closer to Earth the object is, the greater this effect is. The orbital period of the object becomes exactly equal to Earth's orbital period, about 1.5 million kilometers or 1 million miles from Earth. Here the gravitational force utilizes explanation. I'm not getting this, man. I'm not understanding this. Stable equilibrium exists. Unstable equilibrium. It looks like it gets locked into orbit somehow. Natural objects at Lagrangian points. No, I'm not understanding it. Let's go to YouTube and type in Lagrangian points. You ready? Lagrangian points. Let's find out what these things are. What are the Lagrange points? Here we go. Let's see.
Being stuck here on Earth at the bottom of this enormous gravity well really sucks. The amount of energy it takes to escape into the black would make even Captain Reynolds curse up a goal. Would you like to thank?
What happened?
Being stuck here on Earth at the bottom of this enormous gravity well really sucks. The amount of energy it takes to escape into the black would make even Captain Reynolds curse up a Gorham storm. But gravity is a funny way of evening the score, giving and taking in equal measure. And there are special places in the solar system where the forces of gravity nicely balance out. Places that a clever and ambitious solar system spanning civilization could use to get a toehold on the exploration of the universe. These are known as the Lagrange points, or Lagrangian points, or libration points, or just L points. They're named after the French mathematician Joseph Louis Lagrange, who wrote an essay on the three-body problem in 1772. He was actually extending the mathematics of Leonard Euler. Euler discovered the first three Lagrangian points, even though they're not named after him, and then Lagrange turned up the next two. But what are they? When you consider the gravitational interaction between two massive objects like the Earth and the Sun, or the Earth and the Moon, or the Death Star and Alderaan, I just took this example. As I said, when you've got two massive objects, the gravitational forces balance out perfectly in 5 places. In each of these 5 places, you could position a relatively low-mass satellite and maintain its position with very little effort. For example, you could park a space telescope or an orbital colony and you need very little or even zero energy to maintain its position. The most famous and obvious of these is L1. This is the point that's balanced between the gravitational pull of two objects. So for example, you could position a satellite a little above the surface of the moon. The Earth's gravity is pulling it towards the Earth, but the moon's gravity is counteracting the pull of the Earth.
Got it. So it's like a hovering point.
Maintain position. There's an L1 point between the Earth and the moon, and a different spot between the Earth and the Sun, and a different spot between the Sun and Jupiter, etc. There's L1 points everywhere. L2 is located on the same line as the mass, but on the far side. So you get the Sun, Earth, L2 point. Now at this point you're probably wondering why the combined gravity of the two massive objects doesn't just pull that poor satellite down. Now it's important to think about orbital trajectories. The Sun is here, and the Earth is orbiting around it. So the satellite at that L2 point will be in a higher orbit and will be expected to fall behind the Earth as it's moving more slowly around the sun. But the gravitational pull of the Earth pulls it forward, helping to keep it in a stable position. Now, you'll want to play a lot at Kerbal Space Program to really wrap your head around it.
I get it now.
No Man's Sky time isn't helping you at all, except to teach you that hyperdrives are notoriously finicky
I got it.
and never have enough inventory space.
All right, now we know what they are. That's really good. So let's go back to the lecture. All right, so what happens is that at a certain point between two massive bodies, this is what we thought, right? There's like a hover point where you don't need energy to sit in that orbit because it's getting pulled by both sides. It's like a hot girl being chased by two guys, and she can just sit back and go, yeah, it's all good. I need a lift today to the store. Let's see which one of those guys will take me. You see? I guess that's how to understand. That's in my head how I'm understanding. Oh, like between us. Yo, daddy. Yeah, so I feel really good now. Once it's in my head, done. Lagrange points. So Lagrange points basically are points of really hot women, and heaps of guys want her, so she just has to sit back. One guy can bring her lunch. One guy can drive her to wherever she wants to go. Aliens out there. All right. Some of these moons are 60 miles apart. That is just crazy. So Saturn's rings. Here we go. The rings. Hey, rescue farm. We were just talking about Lagrange points. Ring consists of three main segments, A, B, and C rings, separated by empty regions. Rings can't have been formed together with Saturn because material would have been blown away by the particle stream from hot Saturn at time of formation. So the rings happened afterwards. All right, the rings keep getting replenished by passing comets and meteoroids, which I guess means that one day they will die out. So here, have a look at the rings, and we can see these are the rings. That's how big Earth would be against the rings. So the rings are huge, and they are dust particles and stuff, very fine. And there's gaps in between them. So the A, that's the A, the B, and the C. Passing comets. That's right. Did I say comments? Sorry. Passing comments. I like passing comments. That's funnier. You're an idiot. Whoop, gotcha. And then it just keeps going. You're an idiot. You're an idiot. All right. Composition of Saturn's rings. Billions of ice particles, each in their own orbit, moving at large velocities. You would not want to get hit by one of those. The rings must be replenished by impacts on Saturn's moons or small moons that move closest to the planets. This is what it would look like to be inside the rings. Right there. It's like popcorn. And then some moons on orbits close to the rings focus the ring material, keeping the rings confined. Ah, interesting. So the moons are on the outside, like shepherding the rings, like, you know, like the dogs like shepherd the sheep to keep them all in one line. That's quite funny. That's why they're called shepherd moons. So shepherd moons. Oh wow. So these moons are keeping them in check. Have a look at this. So here we have Saturn and the rings. And that's the A, B, and C rings. And then we have here these ring phase. And then, okay, so here we have the moons. And these moons, all the way out, are all keeping those rings in check. So the rings can't go out because the gravity is pushing them back in. You are Gab's shepherd moons. I hope not. I think I'm your shepherd moons. Because I get happy when I see everybody. Saturn. Interesting. So there's also a D ring, which I haven't mentioned yet. A, B, C, and D ring. Interesting stuff. Liquid hydrogen in the core, North Pole. Oh, wow. Rocky core. That's pretty crazy. You are. Me, 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 me. It's like the dog whistle. Everybody come. All right. Now let's study Uranus. I was waiting for that one. All right. So Uranus was discovered by William Herschel in 1781. He discovered Uranus as a slightly extended object, 3.7 arc seconds in diameter. All right, let's now discuss the motion of Uranus. Very unusual orientation of rotation, almost in an orbital plane. possibly result of impact of a large planetesimal during the phase of planet. So there was impact of a large planetesimal on Uranus. Large portions of the planet exposed to eternal sunlight for many years and complete darkness for many years. That's pretty freaky. So for all of us, right, the sun moves from east to west. It rises in the east and sets in the west. On Uranus, it rises in the north and sets in the south. It's like completely wrong. So, you believe he's blushing. So there you go. Basically, look at how it spins. It spins on its side. So what that means is when it's on this side, right, it's always daylight for like, you know, for half of the year. And then here, it's always night for half of the year. Because it's rotating. No wonder it's kinky. So there you go. Uranus lives in darkness for half a year. But I don't know how long the year is for Uranus. Let's find out. So no surface. We are wrong. Yes, that's right. So mostly hydrogen, 26% helium, and a few percentage methane, ammonia, and water vapor. Optical view from Earth, blue color due to methane. In other words, you would die immediately. But basically, yeah, just like the other gas giants, there's no surface. It's just like clouds. So if you went in there, you were just having these geophysics, remember. All right. The structure of the atmosphere of Uranus. And there are 3 cloud layers in Jupiter and Saturn that only occur very deep in Uranus. Uranus cloud layer is difficult to see because of thick atmosphere above it. It also shows belt zone structure. And because of it's dominated by the planet's rotation, not by incidence angle of sunlight, which is quite interesting. All right, have a look at this. So here we have what are we looking at? I don't even know what we're looking at. I don't even know what I'm looking at because it's too blurry. Format relative only. Oh, sorry. Okay. Because Uranus, because it's even Uranus sounds bad. Because Uranus is so cold compared to the other planets, the cloud structures occur at a much deeper level. Because, you know, you need the cold to shrink the clouds and make them form the new levels of cloud level. The ones with different densities. Look at this, the Keck telescope. If there's any troublemakers here, the Keck telescope. That is so terrible. Let's talk about Mars and Venus. Yeah, the Keck telescope. It shows clear variability of the cloud structures of Uranus. Possibly due to seasonal changes of the cloud structures. Interior of Uranus. We have ice and rock. Right in the middle, we have a heavy element core. And I've got to find out what the heavy element core is. We've got here ices of water, methane, and ammonia mixed with hydrogen and silicates. Jesus. The outside is hydrogen and helium. So it's a failed sun, yet again. Here we go. You'll show it compared to the Earth. All right, so that's Uranus. As you can see, the brown eye in the middle. And that is Earth. And Earth is much smaller than Uranus. And that's the ices and rock is the green layer. Methane, ammonia mixed with hydrogen and silicates. And the purple one is hydrogen and helium. This heavy element core, I want to see what that is. You know what will happen in the future? If people can mine these planets, they can mine them and then sell a failed sun. Yeah. All the gas giants are failed suns. Basically, they weren't big enough to have enough internal gravity to squeeze the atoms together to form nuclear fusion and fission. Which is basically what the sun is. It's a nuclear power station, basically. The magnetic field of Uranus. There's no metallic core in Uranus. So you would expect no magnetic field, because the magnetic field comes from the rotating metallic core. And yet there is a magnetic field. It's about 75% as strong as the Earth's, which is pretty huge, right? You got to ask yourself why that's the case. Possibly due to dynamo in liquid water, ammonia, methane solution in Uranus's interior. So they reckon there's something going on in the water interior, which it's spinning and causing this thing. Magnetosphere with weak radiation belts allows the termination of a temperature 17.2 hours. The magnetosphere. The south pole pointed towards the sun. So there are bright aurorae. You know, like what we see in the North Pole of Australia, the North and South Poles. I think it's more than North Pole. The moons of Uranus. 5 largest moons are visible from Earth. And 10 more were discovered afterwards. All right. The 5 largest moons are tidally locked to Uranus. Interior of Uranus's moon, they're all rock and ice. Rock and ice. Have a look at this. They're sort of like little planets, basically. The diameter is only 1,000 miles. And you can see that's just a thick layer of ice. And then here we've got Titania, Umbriel, Ariel, Miranda. Pretty cool. Uranus. Yeah. Uranus. Is it Uranus? Uranus sounds even worse. There's a cream for Uranus moons. That's terrible. The surface of Uranus's moon. Dirty water may have flooded floors of some of the craters in Uranus's moons. That is so bad. The surfaces of Uranus's moons. This is the worst astrophysics lecture. Umbriel and Ariel. Cratered surfaces. Ariel is the brightest of the 5 largest moons. Clear signs of geological activity. Crossed by faults over 10 kilometers deep. Possibly heated by tidal interactions with Miranda and Umbriel. Jeez. Uranus's moon Miranda. Most unusual of the 5 moons detected. It has ovoids. Yeah, Uranus. I don't know which one's worse, Uranus or Uranus. They're both terrible. Uranus ovoids on the moon called Miranda. Oval groove patterns, probably associated with convection currents in the mantle, but not with impacts. There is a cliff near the equator, which is 13 miles or 20 kilometers high. That is like 4 times the height of Everest. That is crazy. All right, the rings of Uranus. Apparent motion of star behind Uranus and rings. Rings of Uranus were discovered through occultations of a background star. That is crazy. So the background star, they were seeing little frequency disturbances, and that's how they knew that it had rings. Amazing. All right, here are the rings of Uranus. If you have a look, you can see them there. There are the rings that go all the way around, and there's outer rings too. Look at that, there's even outer rings outside. It's pretty crazy. Crazy. All right, Neptune. Thank you, we've moved along. Discovered in 1846 at position predicted from gravitational disturbances on Uranus's orbit by J.C. Adams and U.V. Leverrier. Blue-green color from methane in atmosphere 4 times Earth's diameter, 4% smaller than Uranus. All right, so Uranus and Neptune, I guess, are a bit similar. Atmosphere of Neptune. Ooh, they got the great dark spot. Cloud belt structure with high velocity winds, origin not well understood. Darker cyclonic disturbances similar to Great Red Spot on Jupiter, but not long-lived. White cloud features of methane ice crystals. Wow, methane ice. That's very cold. That's very cold. So what do we got here? That's quite crazy. That's from the Hubble Space Telescope over the years. That's pretty crazy stuff. And that there, what are we looking at here? Had cows to create methane. Yeah, it's crazy, huh? And they haven't found the cows yet. They must be invisible cows. The moons of Neptune's. Ooh, there's a moon called Triton, and it orbits Neptune backwards. It is the only moon in all of the solar system discovered that orbits a planet backwards. That's very weird. So the moon would rise in the west and set in the east. The cow that jumped over the moons. Hey, that's really clever. That's really good. All right. Now, the thing about this moon is that it comes close and goes away, and then it comes close, whoosh, and then away. It's very bizarre. Have a look at that. So this is the orbit of the moon. So the moon goes around and it goes backwards. Pretty crazy. So there you go. Boomerang orbits, yeah, pretty much. Yeah, that's right. Surface of Triton. Geez, the temperature is only about 60 Fahrenheit above absolute zero. And absolute zero is like, I don't even know what absolute zero would be. It's right. It's about like 500 Fahrenheit below freezing, something like that. Triton can hold a tenuous atmosphere of nitrogen and some methane. Wow, it is about 10. It's 100,000 times less dense than Earth's atmosphere, but it still has one. Surface composed of ices. Hey, Kevborn. Kevborn is Kevborn is the what do you call it? The Mimi's what do you call preparation. We got Gab Smack temporarily, and then Kevborn will be the new beautiful young and upcoming toy. As well you should. You have good taste. All right, surface composed of ices, nitrogen, methane, carbon monoxide, carbon dioxide. Protege. Possibly cyclic nitrogen ice deposition and re-vaporizing on Triton's south pole, similar to carbon dioxide ice polar cap cycles on Mars. How many planets in the galaxy are like Earth in the Goldilocks zone? Good question. I think it was in 2 astrophysics lectures earlier I said, but it was about 1,000 and something that they found so far that are in the Goldilocks zone. Ongoing surface activity, 100 million years old only. Large basins might have been flooded by liquids from the interior. Ice equivalent of the greenhouse effect may be one of the heat sources of Triton's geological activity. Interesting. So Triton's actually active. So you could probably live on there with a bit of work. The rings of Neptune. Once again, we've got shepherd moons. We've got Mimi and stuff pushing the rings of Neptune into place. Origin of Pluto and Charon. All right, so Pluto and Charon, we know that they're not planets or moons. Pluto and Charon are members of the Kuiper Belt. The Kuiper Belt is the massive belt of rocks that orbit the edge of the solar system. Yeah, because of its different origin from the planets, Pluto is no longer considered a planet, but is the prototype of a new class of dwarf planets. There you go. The family of dwarf planets. We found one called Eris, which is what you could call the 10th planet, but it's a dwarf planet. It's larger than Pluto by 4%, 27% more massive, and 70% further away from the sun than Pluto. That is crazy. That's basically the distance between the sun and Pluto. Actually, the distance between Earth and Pluto, a whole distance again, there's another Pluto. It's called Eris. And then the largest asteroid is about 500 miles in diameter, and it orbits between Mars and Jupiter. Yeah, that's pretty crazy. See, because of Jupiter's massive gravity pull, those ones could not turn into a planet. They prefer the term mass challenged. That's right. We don't want to offend anyone. Mass challenged. All right, that ends our topic on the planets. Now we have to see what the next lecture is for astronomy, Introduction to Astronomy and Astrophysics. Hey, Amy Loren is back. We're just finishing this lecture, and the next one's going to be ethics. Just got to see what's going on. Someone tried to block you on some other channel, clearly. All right. Who's trying to block the Dear Mimi? Everyone leave Mimi alone. You missed the notification. Here we go. The outer planets. We've done it all. All right, that's awesome. We're up to speed with astronomy. And now we've got to see, here are some of the assignments for me. Scope has been all messed up tonight. Oh, that's a bit bizarre. Let's see what we're missing out on with ethics. And that'll be the next one. Resources. All right, readings. Professionalism and ethics. All right, I'm going to do a scope in under 5 minutes. That's a shame. In under 5 minutes, I will be doing our scope on ethics. All right, thank you very much. That concludes our lecture on outer planets. And we're going to do some mathematics later on in the next couple of weeks on astronomy. And the mathematics will be much, much, much simpler. Only Gab could block from here. Ah, always a pleasure. You guys, I'm telling you, without you guys, this is nothing. Honestly. All right. I'll see you all soon.